Hello everyone. We have finished chapter 3 and we are ready to start a new chapter. Before we go into chapter 4, I want to briefly review what we have achieved in chapter 3. We start by asking people a very simple question. Do you prefer bundle A or do you prefer bundle B? We define people's preference based on their answer to those questions. We then introduced utility functions to represent people's preferences. Utility functions are much easier to work with in our analysis compared to working with preferences straight away. We then introduced 3 special types of utility functions that we believe can represent people's preferences over certain kinds of goods. And recall that when we ask people that question, we are assuming that all those consumption bundles come at no cost. In chapter 4, we are going to add into the missing piece the budget constraint, which has to do with how costly are the consumption bundles and how does that affect people's decision. So now let's begin chapter 4. We are going to first define the budget constraint. I'm going to show an example with numbers, and lastly, we will show you what will happen if certain things in our budget constraint changes. I want to motivate by using a simple example first. Suppose you only consume a single good hamburger. You have a total weekly income of $100, and the price for each hamburger is $5. Now the question is, for what amounts of hamburger can you afford? The answer to this question can be found very easily. To derive the answer, we solve the equation that H times PH must be no larger than your income, I. And if we substitute in the numbers, we can find that H, the amount of hamburgers that you can afford, cannot be larger than 20 units. So in this example with a single good, your budget constraint is that you cannot afford hamburgers more than 20 units, or to say that H less than equal to 20 is your budget constraint. The idea is the same when we look at 2 goods. So let's say, suppose you consume both food and clothing, and you have a total income of $800. The price for food is 20, and the price for clothing is 40. If you consume F units of food and C units of clothing, you will be spending 20 times F, so $20 for each unit of food times F unit of food that you consume. So F times 20 is the total expenditure you spend on food. Similarly, $40 each, so $40 per unit of clothing, and you are purchasing or you are consuming C units of clothing. So C times 40 is the total expenditure you spend on clothing. Now, the intuition is that your total expenditure cannot exceed your income. And your total expenditure is the sum of the expenditure spent on food and the expenditure spent on clothing. So your budget constraint is defined by 20 times F plus 40 times C, and this total expenditure cannot exceed your income, so this must be less than or equal to 800. Everything is very intuitive. The definition of budget constraint is saying that it describes the set of bundles that you can afford for given prices and income. So more generally speaking, if you have a total income of I, and the prices of the 2 goods, X and Y, are PX and PY respectively, then your budget constraint is described by the inequality that X times PX plus y times py must be less than or equal to your total income I. So here, defining the budget constraint is very intuitive, but there are certain things you need to be careful of when you draw the budget constraint, and I'm going to do it in this slide. Here I'm using the example of, using the numerical example we just saw, that the budget constraint is 20 times F plus 40 times C less than or equal to 800. You can see this figure as figure 4.1 on the textbook. It is very well drawn, but I'm going to explain step by step how do we get this budget constraint. So on the horizontal axis is the amount of food that you consume, and on the vertical axis is the amount of clothing that you consume. We know that if we replace this inequality sign with an equality sign, this is what we call the budget line. We call this equation the budget line. And we want to draw this on our graph to begin with. And as it is a line, we know that it intersects our two axes at 2 points. And we want to figure out those 2 points. So the first question is, if you spend all of your income purchasing food, how many units can you purchase? We can find the answer pretty quickly. So because each unit of food is $20, if we spend all $800 purchasing food, we can purchase up to 40 units of food. The answer is 800 divided by 20, which equals to 40. And just to note, the answer is the amount of income that you have divided by the price of the food. So this should be P subscript F. And this is the intercept on the horizontal axis. So let's say 40 is at this point. This point is 40. And this is found by calculating I divided by PF. So let me just draw it. This is calculated by your income divided by the price of the food. Now, similarly, we can ask another question. If you spend all your income purchasing clothing, how many units can you purchase? The answer is, again, quite straightforward. We have $800 and each unit of clothing costs $40. So we can purchase up to 20 units of clothing if we spend all of our income buying clothes. And Then the answer is your income divided by the price of clothing. So similarly, we need to draw 20 on this graph, which is likely somewhere here. And this equals to your income divided by the price of clothing, PC. And since the budget line is a straight line, what we need to do is that we need to connect those 2 points, and we know that this is our budget line. So this is our budget line. And its equation is 20F plus 40C equals to 800. Now, any point that is below this budget line, so any point that is in this region are bundles that are going to cost you no more than $800. And any point outside of this region, which is over here, is going to cost you more than $800 and is what you cannot afford. And lastly, we need to find out the slope of this budget constraint. So we can rewrite our equation as following. So if we start from our budget line over here, we can move 20F to the right, 800 minus 20 times F. And we can then divide 40 on each side. So move 20F to the right. Then divide 40 on both sides. So this gives us C equals to 800 divided by 40 minus 20F divided by 40. And we can simplify this. This becomes C equals to 20 minus F divided by 2. So the slope of this budget line is negative 0.5 or negative half. The slope of this budget line is negative half. Let me use a different color. So this is the slope is negative half of our budget line. Now, in this example, I've been using numbers, but let's see what if we change everything into variables. So for example, if we instead of starting with 20F plus 40C less than or equal to 800, what if we start with F times PF plus C times PC to be less than or equal to I? Now we can do the same trick as we have done over here. We can first move our F times PF to the right of our equation. So let's say we have an equal sign here. Because we are looking at the budget line. The budget constraint is what is on and below this budget line. And the budget line is this straight line itself. So if we move F times PF to the right of the equation, we have C times PC equals to I minus F times PF. We then divide both sides by PC. What we get is C equals to I divided by PC minus PF divided by PC times F. So this is the equation we get. We can see that I divided by PC is exactly our intercept over here. And it's the same as our intuition that this intercept tells us that how many units of clothing can we purchase if we spend all our income buying clothing. And this part, the negative PF divided by PC is the slope of our budget line. So this is the slope of our budget line. And this is the general form. So if you were given different PC, PF, and I, the slope and the corresponding intercept will follow those formulas. So this is the slope of our budget line. Oops. Let me redo it. Probably here is better. And if we substitute in the numbers, we have PF, that is 20, and PC, that is 40. This is negative 20 divided by 40, which is exactly negative half. So this is how we can draw our budget constraint on the graph. And what does the slope means? And what does both of the intercept means? So this summarizes what I draw just now. So I was using food and clothing. So in general, we have two goods, X and Y, and our income is capital I. The price of the two goods are PX and PY. So the budget constraint is this inequality, X times PX plus Y times PY, to be less than or equal to I. The budget line is the expression where we replace this less than or equal to sign with equal sign. And the slope of the budget line is the negative value of PX divided by PY. Lastly, we can find the intercept by answering the question, what is the maximum amount of good X or good Y that you can afford if you spend all your income purchasing good X or good Y? The answer will give us the corresponding intercepts. The y-intercept is your income divided by the price of good Y, and the x-intercept is the income divided by the price of good X. So the next question we want to ask is, what will happen if, say, the price of the goods changes or if your income changes? And we are going to do those one by one. So let's first suppose that the price of good X was $20 previously, and it has increased to a new value that is $40. What will happen to the budget line? Oops. So the budget line we just draw, we know that it looks something like this for the old one. So this is our old budget line. With the corresponding intercepts, that is 40 over here and 20 over here. And how do we find this 20? We find this 20 by dividing 800 by 40. This is how we find the 20 over here. And the 40 over here, we find it by dividing 800 by 20, which is the price of the price of food. Now, the new budget line that we are going to draw will probably be different because the price of food has changed. So let's see, does the intercept on the vertical axis change? Actually, it doesn't, right? So if we were to ask how many units of good Y can we purchase if we spend all of our money on good Y, it is still 800 divided by 40, which is 20 units. So we know that the intercept, the Y-intercept, is going to be the same. However, the X-intercept will become different. So as the price of good X increases, if we were continue to spend all of our income on good X, instead of 40 units, we can only purchase 20 units now. Because we can, this 20 units comes from the fact that this is 800 divided by 40, which is your income, divided by the price of good X. So the new intercept on the X-axis is here, which is 20. So the new budget line, we know that its Y-intercept did not change. So the new budget line will be a straight line connecting those 2 points. So this is our new budget line. This is our new budget line. If we were to describe what happens, we can say that the budget line becomes steeper. So the old budget line has a slope of -0.5. The new budget line has a slope of -1. It becomes steeper. The Y-intercept did not change, and the X-intercept becomes smaller. This is what happens when the price of good X increases. Now, in the next slide, I'm going to do the second one. So what if the price of good Y increases? Well, you can probably imagine that we are going to follow a very similar logic. And by doing this again, it's kind of getting you more familiar with the process. So let's start again by drawing the axis. And also we know that the old budget constraint is something like this. Let me draw it further away. All right. This is 40, which is this is 40. This is 20, which is 800 divided by 40. This is the old budget line. And let me have an arrow here. Actually, I don't need the arrow. Now, following very similar argument, as your income did not change and the price for good X did not change, your X-intercept will remain at 40, but it is found out by dividing your income by the price of good X, and neither of those two change. So your X-intercept does not change as well. Your Y-intercept can be found by dividing your income by the new price of good Y. So your y-intercept will now become 800 divided by 50. And if I'm correct, this is going to be 16. That is smaller than 20. So your y-intercept will become somewhere here. That is 16, that is below 20. And as the x-intercept did not change, we know that the new budget line will be a line connecting those 2 points. So this orange line is the new budget line. Now the slope of it becomes flatter, right? So previously the slope was -half. Now, if we want to calculate the slope, we can use the formula that the new slope is equals to the negative value of px divided by py. And if we substitute in the values, px is 20 and py is 50. And this number is -0.4, which is smaller than -0.5 in absolute value. So the slope of the new budget line is steeper. So flatter, the new budget line becomes flatter. Its slope becomes smaller, I should say. All right, this is very similar to what we did in the previous slide. Let's move on. All right, now imagine that instead of change in the prices of each good, your income increased from $800 to $1,000. To draw the budget constraint, the old one is still looks it is still the same, and that this point is 40, and that this point is 20. So let me actually extend our axis a bit. Now, when your income increases, remember how we find each of those intercepts. It depends on our income. So your y-intercept is your income divided by the price of good y. And after your income increases, it becomes 1,000 divided by 40. This gives us 25. The x-intercept is your income divided by the price of good x. And when your income increases, it becomes 1,000 divided by 20, that is 50. And we can find the corresponding intercepts. Your y-intercept is 25. So 25 is possibly here. Your x-intercept becomes 50. 50 is larger than 40. It is to the right of 40. So it is probably somewhere here. And again, we know that it is a straight line connecting those 2 points. So, right. Those 2 lines should be parallel, as we will see in a minute that the slopes are the same. I think I didn't draw very well, but bear with me. Imagine that they are parallel to each other. All right. So both intercepts changed as your income increases. However, the slope of those two lines are the same because the price ratio did not change. Remember, the slope of the budget line is negative px divided by py. And as your price are still $20 and $40, it is going to be negative 20 divided by 40, which is negative half. Oops, 0.5. So although your income increases, your slope does not change. All right. So the slope only depends on the price ratio or the relative price. When neither of the price change, or that if the price change at the same proportion, the slope of the budget line will not change. So in both the old budget line and the new budget line, the slope is negative 0.5 and it's the same. So when your income increases, we can see that our budget line shifts outwards and it shifts parallelly. So this is what the budget line will change if your income increases. All right, let's move on. So this is the second extra credit question for this week. So again, you should pause here, think about it, and provide your answer on iLearn. So the question asks, if the price of good Y, PY, decreases, while the income and the price of good X do not change, what will happen to the slope of the budget line? Will it become steeper? Will it become flatter? Will the slope of the budget line remain the same? Or it is uncertain to answer the question. So you can either take notes of this question or take a screenshot and think about it, and later on, submit your question on iLearn. And I will move on from here. And this here are just some practice problems. So what I did is that I discussed three cases when PX increases alone, when PY increases alone, and when income increases alone. So the practice problem is asking, what will happen if both your income and the price of good X doubles? You can try to figure that out yourself by drawing the graph and making a comparison. And if it helps, you can start with some equations that has numbers in it. It's probably easier than working with the variables. And the second practice problem is to figure out what happens to the budget line or the budget constraint when the price of good Y becomes half as large. All right, so spend some time working on your own with those two practice questions. You can come and ask me in my office hours. You can ask the TA in the discussion section, or you can email me your answer after you have finished it. This is just two practice problems that I for you to think about it. So we have finished describing the budget constraint, and in the next lecture or in the next lecture video, we are going to combine the utility functions or the preferences and the budget constraint to start deriving the optimal choice of a consumer, which is the core question of this first part of our course. So to summarize, the budget constraint describes the set of bundles that are affordable for consumers, given the prices of the goods and the consumer's income. We derived that the intercepts on the x-axis is I divided by the price of good X, and the intercept on the y-axis is the person's income I divided by the price of good Y. We also derived that the slope is the negative value of the relative price ratios. Now, we then draw graphs showing what happens when the price or the income changes. So when we showed that the budget line may rotate either clockwise or anti-clockwise, or it may shift inward or outward when the income changes. And when more than one of the variable changes, the budget line may change as a combination of both rotation and shift. So this is the end for chapter 4.1.